Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to be trying to upload 2 videos every day, one of the very easy or easy difficulty level, and one of an average, hard, or very hard difficulty level. And this is today's hard puzzle. And it's called Enigma Sequence by Xeon Risk. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every box. Counting circles. A digit in a circle indicates exactly how many circles contain that digits. So, for example, if there was a 7 in one of these circles, there would have to be 6 other 7s in these circles, right? And that applies for every digit that's in these circles. Crop key. Numbers that appear in the cells with a white dot between them must be consecutive. So, for example, if this was a 6, this would have to be a 5 or a 7, because it has to be one next to each other, consecutive. Numbers that appears in the cell with a black dot between must have a ratio of 1 to 2. So if this was a 2, this would have to be a 1 or a 4, because it has to be a 1 to 2 ratio. Parity. High, low, prime, composite, I guess. So high 6, 7, 8, 9, low 1, 2, 3, 4, prime 2, 3, 5, 7, or composite, which is 4, 6, 8, 9. Each color of highlighted circles belongs to a parity set. Which color belongs with which set must be determined by the solver. So basically, all the purples are from one set. So it could be either high, low, a prime number, or some composite number, which means that it is not prime essentially, and it's not 1. 1 is a very unique number. So the greens are 1, the yellows are another 1, the reds are another 1, and the purples are another 1. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So first thing first, let's count up all the circles, because that's okay. So basically, the circles kind of act like a killer cage, where all the digits in the circles add up to a certain number, but we don't know how many digits there are. That's the only issue. So there's 4 in line in row 1. There's 3. 4 plus 3 plus 4, which is 11. Plus 1 is 12. Plus 4 is 16. Plus 3 is 19. Plus 4 is 23. Plus 1 is 24. Plus 3 is 27. And let's just make sure we have. So it's 4 plus 3, it's 8. 7 plus 1 is 8. Plus 3 is 11. Plus 4 is 15. Plus 1 is 16. Plus 4 is 20. Plus 3 is 23. And plus 4 is 27. So again, we have 27 circles. Unique digits, we know there's at least 5, because in box 3 there are 5 unique digits. So it could be 5 up to, so 27. It's 5 or 6 unique digits, because if you have 7 unique digits, that would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 at the minimum, which would be 28. So there are 5 or 6 unique digits, all of which add up to 27. Okay. There are digits in each box. Okay. There are digits within each box, so 9 is a possibility. There's also a circle in each row, which means 9 is still a possibility. The interesting thing is, okay, so one of them has to be prime, one of them has to be composite, one of them has to be low, and one of them has to be high. So you have 3 digits You have 5 digits from one, 5 digits from another, but 3 unique ones at most. You have 3 unique ones from one, 3 unique ones from another, 2 unique ones from one, and 2 unique ones from another. Okay, so what are the possibilities? You could have. Okay, so say the 3 unique ones. Okay, so for one thing, you cannot have 6 plus 7 plus 8 plus 9. So if we know there's one high, so it cannot be 6 plus 7 plus 8 plus 9. Can you have any of the can you have 3 of 6, 7, 8, and 9? I don't know if you can. So the minimum would be 6 plus 7 plus 8, which is 21. You could have 1 plus 2 plus 3. Oh, wait, there's 5 possible, too. Uh... Oh, but there's... Okay, so there has to be 3 unique digits in 2 of the sets. And 2 unique digits in the other 2 sets. If there's 3 unique digits, say that the high was one of the 3 unique digit ones, right? There has to be another 3 that would match. It could be 6, 7, 8, and 1, 2, 3. So if there's 3 highs, it has to be matched with 3 lows. You cannot have high and comp be the 2, 3 sets, right? Because then the only ones that match there are 6, 8, and 9. Otherwise, you would have to have like 6, 7, 8 plus 4. Which is possible, actually. Hold up. No, it's not possible. Wait, it could be possible. It could be 2. Okay, so that's possible. Okay, so if 6, 7, 8, 9 is the set of 3, if it's low, if low is the other set of 3, that would be 1, 2, 3, right? With 6, 7, 8. And that would add up to 27. So it could be 1, 2, 3, 6, 7, 8. So what are the possibilities? So it could be 1, 2, 3, 6, 7, 8 is one set of in all the circles. That's if it's high and low. If it's high and prime, does that work? Yes, it could be, right? Okay, so there's also 2 unique digits too, I forgot, right? So there's 2 unique digits for the others, right? So 1, 2, 3, 6, 7, 8. Um, well, one other thing. Okay, so one thing we need to do is these have to be 1, 2, 3, 4, 6, 8. This is also 1, 2, 3, 4, 6, 8, and these are also 1, 2, 3, 4, 6, 8, right? Because the only digits that can work in a between two black crop key dots are 1 to 2, which is 1 to 2 ratio, 2 to 4, which is a 1 to 2 ratio, 3 to 6, or 4 to 8. So those are the only possibilities. I don't know what that tells us. Okay. So again, for the high and low, you could have potentially 1, 2, 3, 6, 7, 8. The unique highs would be 6, 7, 8 if they're 3. The unique lows would be 1, 2, 3, assuming the low is the other set of 3. For the parity, it could be 2, 3, and 7. So those work. For the other parity, it would have to be 6 and 8 specifically. So that's if it's 1, 2, 3, 6, 7. That's if you have a high and a low as the unique sets of 3. If it's high and prime, it could again be 6, 7, 8, and 1, 2, 3. Because it would be 2, 3, 7. Not sure I like this rep. So what are the okay? So 27. You could have 5 digits adding up to 27, or 6 digits adding up to 27. The possibilities for the 3 digits, 6 digits. Ooh. So 27, right? It could be any of the 1 plus 2 plus 3. 6 digits, right? 1 plus 2 plus 3 plus 4 plus 8 plus 9. So that would possibly work. 1, 2, 3, 4, 8, 9. 1, 2, 3, 5, 7, 9. 1, 2, 3, 6, 7, 8. Okay, so yeah, let's just the possibilities. 1, 2, 3, 6, 7, 8. 1, 2. Okay, let's clear all these. So 1, 2, 3, 4 plus 8, 9. That's 27. 1, 2, 3, 5, 7, 9. So that's 11 plus 16, which is 27. 1, 2, 3, 6 plus 7, 8. So that's 12 plus 15. So those are 3 sixes. You can have 1, 2, 4, and 5, which is 12. So you need it at, so it could be 6, 9. 1, 2, 4, 5, 7, 8. That's possible. 1, 2. So those are all the 1, 2, 4, 5s possible. You can get 1, 2, 4, 6. Wait, no, that doesn't work. 1, 2, 4, 6 is 13. And that would be 5, 9. So that's already taken 1, 2, 4, 6 isn't anything special. 1, 2, 5, 6. 1, 2, 5, 6 means 14. So you have 13. So that'd be 4, 9 is the only one. So these are the only sets of 6 that can be 1, 2, 3, 4, 8, 9. 1, 2, 3, 5, 7, 9. 1, 2, 3, 6, 7, 8. 1, 2, 4, 5, 6, 9. 1, 2, 4, 5, 7, 8. Okay, what are the sets of 5? There's no cages. What are the sets of 5 we can do? Okay, so obviously not 1, 2, 3, 4, 9. 1, 2, 3 doesn't work with anything. It could be 1, 2, 4. No, it can't be 1, 2, 4, 8, 9. It could be up to 1, 2, 7, 8, 9. Yeah, 1, 2, 7, 8, 9 works. 1, 2, 7, 8, 9. 1, 3, 6, 8, 9. 1, 4. It could be 5, 8, 9, or 1, 4. 6, 7. Does 6, 7, 9? 1, 4 is, yeah, 6, 7, 9. So, right, it could be 1, 2 with 24, 1, 3 with 6, 8, 9, 1 4 with 5 8 9 or 6 7 9. 1 5. Can it 1 5 work? So it'd have to 27 minus 6 is 21. So it'd have to be 4 8 9 21. It could be 1 5 6 7 8. So that works. And those are all the ones that are unique. Right? Anytime you have 1 6, it could be anything that's less than that, but yeah. So that's ones that are unique. We have 2 3. That's 5. So it could be 5 8 9. Right? So this is 10 plus 17. Yep. 2 3 6 7 9 also works. 2 3. You can't. Those are all the 2 3s. Right? Right. So now we go 2 4. 2 4. It could be 5 7 9. Right? 2 4 is 6 minus 27 is 21. So 5 7 9 is 21. 2 4 5 7 9. 2 4 6 7 8 also works. And those are the only two. So then you have 2 5. So it's 2 3 2 4 2 5. 2 5. It can't be 6 7 8. I don't think you can actually have a 2 and a 5. That's not already taken care of. 2 5, you would have to have something less than 5 with it, right? Because 2 5 6 7 8 is 28. Yeah, so that can't work. So you cannot have 2 5. Okay. So that's all the twos. Then we have 3. 3 4. So that's 7 plus 20. So 5 6 and 9. I think that's the only one, right? 3 4 5 6 9. So that would be 9 plus 9 plus 9, which would be, yeah. So 3 4 5 6 9. 3 4 5 7 8 works also. 7 8 works. And those are the only 3 4s. Because 3 4 plus 6 7 8 doesn't work. That's 28, and everything else is too big. So how about 3 5? 3 5 means that's 8. So 27 minus 8 is 19. And there's no, yeah, so it cannot be 3 and 5. So 4 and 5, it does not work because it's 9. And then the next one would be 6 7 8. So that's 21. So that would be 30 total. So that can't be worked. Okay, so these are all the sets of 5 that work. These are all the sets of 6 that work. Okay, we just have to be able to apply those to all the unique numbers, right? So 1, 2, 7, 8, 9. You could have 3 high. 1, 2, 7, 8, 9. It would be 2 lows. 1, 2, 7, 8, 9. So 1, 2, 7, 8, 9 fits 3 high. It fits 2 low. It fits 2 prime. And it fits 2 comp. But the problem is we have 3 unique here. We have 3 unique here. So it doesn't fit that. So 1, 2, 7, 9, 8, 9 does not work. 1, 3, 6, 8, 9 fits 3 high, 1, 2 lows, 1 prime, which is not, so that's not possible. So 1, 3, 6, 8, 9 does not work. 1, 4, 5, 8, 9 fits 2 high, 2 low, and 1 prime. So that doesn't work. 1, 4, 6, 7, 9. 6, 7, 9 fits 3 high, 2 low, 1, 4, 6, 7, and 1 prime. So that doesn't work. 1, 5, 6, 7, 8. 6, 7, 8 fits 3 high but 1 low, so that doesn't work. 2, 3, 5, 8, 9. 8, 9 fits 2 high, 2 low. 2, 3, 5, it fits 3 primes, but 2 comps. So there's there's no other set that has 3 unique ones. So that does not work. 2, 3, 6, 7, 9. 6, 7, 9 hits 3 highs, 2 lows, 2, 3, 7, 3 primes, and 2 composites. So 2, 3, 6, 7, 9 is possible. So 2, 3, 6, 7, 9 is possible. 2, 3, 6, 7, 9 is possible. 2, 4, 5, 7, 9 fits 2 high, 2 low, 3 composites, 3 primes, but only 2 composites. So that's not enough. There's not 3 enough. 2, 4, 6, 7, 8 fits 3 high, 2 low, 2 prime, and 3 composites. So 2, 4, 6, 7, 8 also works. 3, 4, 5, 6, 9. So 6 and 9 is too high. 3 and 4 is too low. 3 and 5 is 2 prime, but that doesn't work then. We don't have 2 sets of 3. 3, 4, 5, 7, 8. 7, 8 is high. 3, 4 is low. 3, 5, 7 is prime, but 4 and 8 is 2 comps, so that doesn't work. So of the 5 sets, you could be 2, 3, 6, 7, 9, or 2, 4, 6, 7, 8. So then let's move all the sets of 6 together. 1, 2, 3, 4, 8, 9. 1, 2, 3, 5, 7, 9. 1, 2, 3, 6, 7, 8. 1, 2, 4, 5, 6, 9. 1, 2, 4, 5, 7, 8. Okay, so those are the possibilities. 1, 2, 3, 4, 8, 9 fits 2 high, all 4 lows. 2, 3, 5, 7, 2 primes, and 4, 8, 9, 3 composites. 1, 2, 3, 5, 7, 9 fits 2 high, 3 lows, 4 primes, and 1 composite, which doesn't work then. It has to be 2, at least, composites. So this is 1, 2, 3, 6, 7, 8. This one works, we know for certain, right? 6, 7, 8 fits 3 highs. 1, 2, 3 fits 3 lows. 2, 3, 7, that's 3 composites. And 6 and 8 fits 2 composites, so that works. So that's a valid one. 1, 2, 4, 5, 6, 9. So 6 and 9 fits 2 highs. 1, 2, 4 fits 3 lows. 2 and 5 fits 2 primes. 4, 6, 9 fits 3 composites, so that works. 1, 2, 4, 5, 6, 9. And 1, 2, 4, 5, 7, 8. So 7, 8 is 2 high. 1, 2, 4 is 3 lows. 2, 5, 7 is 3 primes. And 4, 8 is 2 composites. So that also works. So 1, 2, 4, 5, 7, 8. So those are the possibilities for all the circles. It's 2, that could be 2, 3, 6, 7, 9, 2, 4, 6, 7, 8. 1, 2, 3, 4. Okay. Interesting. Okay. If there is a 9 that qualifies for both, it has to be in the purple and the yellow, which means it has to be in a 3 set and then a 2 set, or 2 or more set, essentially, right? So say it was 2, 3, 6, 7, 9. This would have to be 9, and this would have to be 9. So for the 3 set, 2, 3, 6, 7, 9, it'd be high. So that could be a high. And then 6, 9, it could be comparable, right? So this would be 9, this would be 9, this would be 9. So that seems reasonable. It seems like it works. What about 1, 2, 3, 4, 8, 9? So can you actually have sets of sixes? Actually, let me think about that. Can you have 1, 2, 3, 4, 8, 9 is really kind of the question, right? So say you have 9 here and 9 here, right? You would have to have eight. Oh, you can't have 1, 2, 3, 4, 8, 9. There's no 8 in this. Well, I guess this could be 8. So you'd have to have an 8 in every other row. So this would have to have an 8, 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 this. Oh, no, there's 2 rows that doesn't have an 8. So 1, 2, 3, 4, 8, and 9 does not work, actually. So let's just move. So no 4, 9. Let's move 6, 7, 8 here. So 1, 2, 4, 5, 6, 9. And 1, 2, 4, 5, 7, 8. So those are the possibilities for the circles now. We've eliminated 1, 2, 3, 4, 8, 9. Can it have a 9 in the others, right? I guess so, right? Hold up. Okay, so 2, 3, 6, 7, 9. So that would mean that's a 9 and this is 9, right? Because those are the only ones for those rows specifically. So 7 would have to be in all the others, right? You would have to have a 9 here. You'd have to have a 9 here. So we know that 6, 7, 9 would be the high if you have 2, 3, 6, 7, 9. So that would have to be high for the sets of 3. So then this would have to be 6 and 3, and this would be 7 or 9. This would be a 7 or 9. 2 or 3 would be low. 2, 3, and 7 would be the comp. So this would have to be 2, 3, or 7. So this would have to be 2. This would be 3 or 7. This would be 3 or so this would be 3. This would be 7. This would have to be 1 or 4. Right? So that works. So that's 2, 3, 7, 6. So this would be this doesn't work. So it cannot be 2, 3, 6, 7, 9 because this would have to be 6, 7, 9. And then the 3 cannot be in both of these. So 2, 3, 6, 7, 9 does not work. So this does not work. 2, 4, 6, 7, 8. That might work. So 2, 4, 6, 7, 8. So that's an interesting one. So then this would be 2, 4, 6, 7, 8. This would be 2, 4, 6, 7, 8. This is 2, 4, 6, 7, 8. This is 2, 4, 6, 7, 8. This is 2, 4, 6, 7, 8. Right? So this cannot be 2, 4, 6, 7, 8. So this is 1, 3. So this would have to be 2 or 4. Okay. This could not be 3. So this cannot be 1. So it's 2, 4, 6, 8. So this can't be 6. 2, 4, 6, 7, 8. Seems like it works okay here. 7, 8. 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. Okay, hold on. Let's divide it into the sets of 3 and 2, right? So 2, 4, 6, 7, 8. The high has to be a set of 3. The high has to be a set of 3. 2, 4 is low. 2, 4, 6, 7, 8. Wait. I don't think that works. 6, 7, 8 is high, so that's a set of 3 that's high. 2 and 4 are low, so that's 2 for that set. 2 and 7 are the primes. Oh, 4, 6, 8. 4, 6, 8. 4, 6, 8. So this is either... Okay, so this 2, 4, 6, 7, 8 means the composites are the 4, 6, 8s. And this has to be high for 6, 7, 8. But this has all 5 of them. So this would be 2, 4, 6, 7, and 8, which means this can't be 2, 4, 6, or 8. So this is 1 or 3, which forces this to be 2 or 4. Only 4 fits the set of 3. So this would have to be 4, 6, and 8. So this is 6 and 8. This is 6 and 8, right? This has to be a set of 6, 7, and 8. So this... Wait, 4 doesn't work. No. Okay, so this is 2 and 6. I don't know why I did. So 2 can only be a set... 2 can only be part of 2 and 4 or 2 and 7. So this cannot be 7. So this is 6. This becomes 3. This is either 7, 8, 7, 8, or 4, 8, 4, 8, right? So this is 2. 2 and 7, or 2, no, can't, yeah, 2 or 7 or 2 or 4. We know 8's here. So this set of 3 is the other one. So it's 4, 6, 8 or 6, 7, 8. So this is 4, 6, 8. So this can't be, or 6, 7, 8. So the 6 is always here. The 8 is always in here. This can't be 7. So this is 4 or 8. If it's 4, it can be 2, but we know the 2's here, so this can't be 2. So this would, if this is 4, this is 8, which is not possible. Because we know the 8's are in here, right? It's either 6, 7, 8 or 4, 6, 8. So this can't be 8. Therefore, this has to be 8. This is 8. This is 4. So this forces this to be 6, 7. That can't be 6, 7. This can't be 4, 4. So this is 4 and 8. This is 6, 7, 6, 7. This is 8. Okay. So this is 6. This would be 6. This would be 7. We know this is some combination of 4, 6, and 8. So this is 4, 6, and 8. This is 4, 6, and 8. This is 6, 7, 8. This is one of 6, 7, 8. So this would be... Okay, so we have the highs, we have the composites. Now we need the low and the primes. So this is either 2, 4 or 2, 7. 2, 4 or 2, 7. This can't be 4. This can't be 7. This is 2, 4 or 7. This is 2, 4 or 2, 7. This is 2, 4 or 2, 7. Right? So far that seems okay. This is 2 and 6. This has to be 8. So this can't be 8. So this one does not have an 8 in this row. So therefore 8 has to be in all the others. So this is 8. So this can't be 8. This can't be an 8. So it cannot be 2, 4, 6, 7, 8. So we've eliminated all the 5 sets. So there has to be sets of 6. So now we need to pay attention to all the sets of 6s now that are possible. And there's only 3 of those left. Right? Okay. So all the 5 sets are not possible. So we have 3 sets of 6 sets that are possible. So 1, 2, 4, 5, 7, 8. So 1, 2, 3, 6, 7, 8 works. 1, 2, 4, 5, 6, 9 so far works. 1, 2, 4, 5, 7, 8 also possibly works. So those are the possibilities. We don't know what other ones we have necessarily. Okay. I'm thinking the ones with the 5 are the less likely ones. Yeah, because the ones with the 5 are the less likely ones because the 5 forces things to be in weird states, right? 5 is not part of high, it's not part of low, and it's not part of composite. The only one it is part of is the prime numbers. Therefore, 5 limits things in ways that other digits don't. And specifically, let's target 1, 2, 4, 5, 6, 9, because we know that the 9 would have to be then here and here, right? So 9 would have to be one part of a 3 set, a 3 unique set. So, and is that possible? So 6, 7, 8, 6, and 9 are 2 for high. 1, 2, 3, 4 has 3 lows. 2, 3, 5, 7. Oh, 4, 6, and 9 has the composite. So this would be. Okay, so this would have to be 4, 6, and 9. So this is 4 and 6, which means this is 3 and 2 or 8. This is 4, 6, 9. This is 4, 6, 9. So this is 4, 6, right? That's the composite. So this would be. And 9 would have to be part of 2. So this would have to be 6 and 9. Is that right? For the highs, right? We have composite as 4, 6, 9, right? So this would be 6 and 9. This would be 6 and 9. The green one, then. So it's a set of 3. So it'd have to be 1, 2, and 4. So this is 1, 2, 4, 1, 2, 4, 1, 2, 4. So this cannot be 1, 2, and 4. So this can't be 1. This can't be 3. This can't be 6. So this has to be 8. This is 4. So this cannot be 4. This cannot be 4. This would have to be 6, which makes that 3. So no 6, no 6. This is 4, 9. This is 4. This would have to be the 9. Because it's the only one. And this would have to be 9. Which doesn't work. Right. So the 9 would have to be part of 3 different sets, which it can't be. If there is a 9. So that eliminates all the possibilities for 9. So 9 can never be part of this. Yeah, we should have been able to figure that out pretty quickly. Because this would have to be 9, this would have to be 9, and where is the 9 in box 8? It would have to be one of the red ones. So it's part of 3 sets then, if that's the case. And I don't think anything is part of 3 sets, right? So it cannot be 1, 2, 4, 5, 6, 9. Yeah. Let's remove those. Okay, so cannot be 1, 2, 4, 5, 6, 9. So there's only 2 possibilities left: 1, 2, 3, 6, 7, 8, and 1, 2, 4, 5, 7, 8. Right? So the possibilities are 1, 2, 3, 6, 7, 8, and 1, 2, 4, 5, 7, 8. So those are the only possibilities. So they both have to have 7 and 8 in them. 7 and 8 are part of the same ones for high. Okay. Okay, so 1, 2, 4, 5, 7, 8. 8 can only be part of the sets of 2, right? It can be only part with high, which is 7, 8, or composite, which is 4, 8. The prime works for 3, so it's 2, 5, and 7, and then the low works for 1, 2, and 4, right? So if it's 1, 2, 4, 5, 7, 8, 8 can only be part of yellow and red. So 8 has to be here. 8 cannot be in the purple. 8 cannot be part of green. So cannot be part of purple, so there's no 8s here. So therefore, there has to be an 8 in every other one. So this is 8, we know, because it has to be part of that. It has to be part of the red, right? It has to be part of the red. It has to be part of the yellow. It also has to be here because we know it cannot be in this purple. So that row is completely taken out. So every other row has to be accounted for. So 8 has to be here. Which doesn't work. So it cannot be 1, 2, 4, 5, 7, 8 because 8 cannot be part of the greens also. So it has to be 1, 2, 3, 6, 7, 8. We know that for certain then. So we have to find 1, 2, 3, 6, 7, and 8. So 1, 2, 3 is low, and 6, 7, 8 is the high. So green is either high or low. Purple is also either high or low. For composite, it could be. Oh, actually, no. There's a whole bunch of variety. So for the prime, okay. For the prime, it could be 2, 3, 7, right? So it's 1, 2, 3, 6, 7, 8. For the composite, it has to be 6 and 8. Okay, so one of the composites is 6 and 8. Okay. So the ones that 8 are part of has to. Okay, that's interesting too. Yeah. That could have been much faster. Anyways, yeah. So basically, we know in each set green makes up one set of circles, right? Yellow makes up one set of circles. Red makes up one set of circles. There is no number that fits in all three or in three different sets, period. So that would have eliminated 9 from the very start. So we should have been able to figure that out almost immediately. 8 has to be in either green, yellow. It has to be part of 2 out of those 3. So it has to be part of green, yellow, and or red. But we know it can only be part of 2 of those 3. And so therefore it has to be part of green, 2 out of 3 of green, yellow, and red. So 8 can never be part of purple. And since 8 can never be part of purple, we know that. So for example, in box 1, there's only green cells in the circles. In box 4, we know there's only green yellow cells in the circles. In box 8, we know only red cells are in the box in the circle. Therefore, 8 can only be in 2 out of those 3 boxes. Therefore, 8 has to be in all the other boxes. And we know that 8 also cannot be part of purple. So this specific circle has to be 8, which means this is 4. So this is 4. Right, so 8 has to be in all the other circles. So this cannot be 8. All the other boxes, sorry. So this is 8. This is 8. I guess it could be in yellow. So this could be in the yellow. It cannot, okay, so 8 cannot be here. 8 cannot be in this row. Therefore, this has to be 8. So yellow has to be one of the ones with an 8. So it's either it has to be either 6, 8, or it's 6, 7, 8, right? So this cannot be 8 here. So we know 8 cannot be in the purples. So 8 also cannot be here. So 8 is one of these. So 8 cannot be in row 4. 8 has to be in box 1 somewhere, because row 4 is taken. Wait, no, that doesn't work. Oh man, okay, wait. Okay, so I think there has to be an 8 or a 9, right? If there's no 8 or 9, oh, I missed one. Did I? No. There's 27. 1 to 7 adds up to 28. So it cannot be 1. Oh, 2, 3, 4, 5, 6, 7. Okay, I think we've shown it can't be 8 or 9. I missed one. Yes, I missed 2, 3, 4, 5, 6, 7. Excuse me. So it cannot be 8 or 9. I think we've shown. 9, obviously, it can't be, because 9 would have to be part of purple and yellow. But then it also would have to be part of red and green. And that's not possible, right? So 9 is completely out. Now we've just shown 8 cannot be possible, right? 8 has to be part of 2 out of green, yellow, or red. But if that's the case, it can never be part of purple. So 8 can never be here. But that eliminates row 4 and row 6 as the row where 8 cannot be in a circle. So 8 has to be in a circle for every other one. But that means it has to be in a circle for the red, the yellow, and the green. But none of those digits satisfy that. Therefore, you cannot have an 8 or a 9 in the solution. And I forgot one solution because I went through all the ones in the 6 possibilities, but I forgot there could also be 2, 3, 4, 5, 6, 7, which has to be the one that actually works. So then we have 2, 3, 4, 5, 6, 7. 7. Oh, okay. So 2, 3, 4, 5, 6, 7. 6, 7 is the high. 2, 3, 4 is low. 2, 3, 5, and 7 work for prime, and 4, 6 has to be the composite. So you have either a high of 6, 7. So this is either 6, 7, or it's 4, 6. So either way, you have the 6 here. So we know that's one of the 6s. This is also 4, 6. This is either 6, 7. We know it's 6, or it's 4, 6, or it's 6, 7, right? Those are the only ones. So 6, 7 is the high, and 4, 6 is the composite. It could be 2, 3, 5, and 7 for the prime, though. So this is 4, 6, or 7, and we don't know which one this is. So purple could be either low, in which case it's 2, 3, and 4, or it could be the prime, which it could be 2, 3, 5, or 7. Okay. We know 6 cannot be part of green, and it cannot be part of purple. Four could be part of purple or green. Okay. 7 can only be part of 2 sets also. So if 7 can only be parts of 2 sets also. So it's either it cannot be red and yellow, but it has to be one of red or yellow, right? Say it's part of purple. Sorry, say it's not part of purple. Say it's part of green. So this makes up for 7. But so one of these would be 7. So specifically it'd have to be this. Purple cannot be 7. So 7 would have to be here. So we have row 1 as a 7. Row 6 cannot be a 7. If it's red, it cannot be part of yellow. So then row 3 could not be 7. But then it would have to be part of yellow, which is not possible then. Because we already said that red was yellow. So it was a 7. So if it's part of green, it cannot be part of purple. So it would have to be part of yellow. So it would be yellow, this is 7. Yellow, this is 7, right? So this could be 7, 7, 7. Okay, so if it's part of green, one of these would be 7. This can't be 7, so this would be 6. This would be 7. This would have to be 7. Because if it's not, then it would have to be part of red too, which doesn't work. So this is 4, 6. This is 4, 6. This can't be 6. So this is part of 7. This is part of 7. This is part of 7. The problem is then this would have to be 7, but it's not possible for that to be 7. Because it doesn't fit the black Kropke dots. So 7 cannot be part of the green. 7 has to be part of the purple. Which means this set, so this is 2, 3, 5, and 7. So this has to be 2 or 3. This is 2, 3, 5, 7. This is 2, 3, 5, 7. This is 2, 3, 5, 7. This is 2, 3, 5, 7, right? And 7 is part of the red ones or the yellow ones. We don't know which because it works with 6. So the other one has to be 2, 3, and 4. So this is 2, 3, or 4. This is 2, 3, or 4. This has to be 2, 3, or 4. This is 2, 3, or 4. This is 2, 3, or 4. Which means this is 1, 6, or 8. Because we have all 3 here, right? This is 2, 3, 5, 7. We have... So where can the 6s be? 6 cannot be here. 6 could be here. This is 2 or 3. So could be 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And all of these are also 2, 3, 4, 5, 6, 7. Right? 7 cannot be here. 7's in one of these two, but only one. Therefore, 7 has to be in one of these two. It can't be here. 7 has to be in one of these 5. 7's in one of these. So if this is 7, so can the red be 7 then in that case? So let's say this is 6, 7, 6, 7. This is 4, 6, 4, 6, 4, 6. So this would have to be 6 or 7, but this cannot be 6 or 7. So this would have to be 7. And this would have to be 7. So if the reds are the 7s, if the reds are the 7s, that means one of these two is 7. One of these two is 7. That doesn't work. So this cannot be 7. So that's 3 digits that can't be 7. So we know this cannot be, the red cannot be 7. If the red is 7, even if the purple is 7, if the red is 7, the yellow cannot be 7. So we have 2 boxes already that can't be 7. So 7 has to be in all the other boxes. And since 7 can't be yellow, 7 has to be one of these specific 2. But we also know box 9, 7 has to be in one of those 3. But then there's 3 7s in row 7 and row 9, which is not possible. So this can never be 4, this can never be 6, 7. So this has to be 4 and 6, which means it's the composite. And this has to be 6 and 7, which means it's the, so one of these is 7. One of these is 7. So all the 7s have to be in all boxes now, because 1 does not have a 7, and then box 8 does not have a 7. So all the other boxes have to have a 7s. So this has to be a 7. This is 6. This is 7. So this can't be 7. So this has to be 7. This can't be 7. This can't be 7. So the 7 has to be here, which means this can't be 7. 7 can be one of those two. We don't know it. Okay, so this is also 6 or 7. So this can't be 6, which means that can't be 3. So this is 3. So this can't be 3. This can't be 7. This can't be 6, so that can't be 3. We also know it's 2, 4, or 6. So if it's 2, this could be 1 or 4. If it's 4, it could be 2 or 8. If it's 6, it could be 3. So 6 is one of these two. 6 cannot be in box 6. 6 cannot be in box 1. 6 could be here. So 7 is one of these 3. So 7 is also one of these 4. 7 has to be one of those 4. So 7 is one of these 2. 7's one of these 3. 7's one of these 4. So 7's one of these 2. So this can't be 7. This is 7. One of these is 7. 6 is in... Okay. In the rows, in the columns 1 through 3, 6 can only be in 2 of them. So that's 1 that we do not have. In the columns 4 through 6, it can only be in 2 of them. So that's 2 that we do not have. And then in box 6, it cannot be. So that's 3 6s that cannot be in circles. Therefore, there has to be in box 3 and box 9 a 6. So, and 6 cannot be with the purples, so we know 6 is here. So 6 has to be one of these two squares. 6 could be one of these three. Oh, 6 has to be in one of these three. And then 6 has to be in one of these two. But we know 6 can be here, here, and here, and here. So we already have eliminated 6 from row 7 and row 9 because 6 has to be in one of these two boxes in one of these two cells in box 8 and in one of these three cells in box 9 because we've eliminated 6 from once from columns 1 through 3, once from columns 4 through 6, actually specifically column 6, and therefore 7 through 9 you have to have 2, and there cannot be 1 in box 8, so there has to be 1 in box 3 and 1 in box 9. So 6 has to be one of these 3. 6 has to be one of these 2, which eliminates 6 from any other possibility in box 7. But we know there has to be a 6 in box 7, so this is 6. So this can't be 6. We know 7 cannot be in box 8 and it cannot be in box 1. So it has to be in box 3, or sorry, 7. Well, all the other boxes. So the only possibility for 7 is to be here. So this has to be 7. This can't be 7. This can't be 7. So again, we know green is low. 6 and yellow is high. Red is composite and purple is prime. So 6 has to be here, which means this cannot be 6. 7 can be in one of the 5. We don't know which. This is 2 or 3. It cannot be 3 because if it were 3, that means 6 is outside the box, and we know that 6 has to be inside one of this one. Sorry, 6 has to be in a circle in that box, and it cannot. And if we had this number be 3, it would have to be 6 outside one of the circles of that box. So it cannot be 3. So this is 2. So this one specifically is 2, which makes that 4. So this is 8. This can't be 4. And this is 2, 3, right? So there's no 2 here. There's no 2. This is either 1 or 4, but it can't be 4. So this is 1. So this can't be 2. This can't be 2. This can't be 2 or 4. So we have all the 2s because 2 can only be here and 2 can only be one of these 2. So this can't be 2. So there's no 2 in any of the other circles. So this has to be 3 and 4. So this can't be 2. It can't be 4 because of these green ones. So this has to be 6, which makes that 3. This is 4. This is 6. This can't be 3. This has to be 5. So no 4 or 5. No 4 or 5. This can't be 6. So this has to be a 6-7 pair. So this is 6-7. This is 6-7. This can't be 2 anymore. This is 5. So this can't be 5. No 2. No 2. No 5 or 6 here. No 3 or 6. Wait, we've got a problem. Oh, no, no. Okay, then we're good. Because we have the 2 6s we needed for column 4, 5, and 6. So that's fine. So this is 6. This is 6. So we have 2 3s. We have another 2 3s. Okay, so 7s. We have all the 7s account. Okay, so one of these 4 is 7. We don't know. One of these 3 is 7. We don't know which. How many 6s do we have? We have 5 6s. One of these is 6, and one of these is 6. So that's good. 5s. How many 5s do we have? We have 2 5s. We have to have 5s. So this can't contain a 5. So that's one that can't contain one box that can contain a 5. This can't contain a 5. That's 2 boxes can't contain a 5. This can't contain a 5. That's 3 boxes, and here is the 4th box. So that's 4 boxes that cannot contain a 5. Therefore, all the other boxes must contain a 5. And this is the only place for 5 in this box, so this has to be a 5. This is the only 5 that can be in this box, so this has to be a 5. And then the 5 has to be in one of those 4 boxes. We don't know which. one of these 4 cells in this box. 5 cannot be here, 5 cannot be here, 5 cannot be here or here. So this is 5. 5 can't be here, 5 can't be here. So 5 has to be one of these 2. So therefore 5 is one of those 2. Which means 5 has to be one of those. Okay, so 2 is already accounted for. 3's in one of them. So this is 7 and 3 or 4. This is also, so we know 5, 6, and 7 have to be in the circles in this box. Either 3 or 4 is. Either 3 or 4 is here too. But we can only have one of each, right? Because we have 4 here, we have 4 here, and we have 4 here. So that's 3 times where 4 is, specifically. If this is 4, this would have to be 4 and 6. We don't know very much of that. Okay, where can 1 be in box 1? 1 can be here. This is 3 and wow, that worked very well. This cannot be 6. If it's 6, it would have to be 5 and 7, which is not possible. So this is 7. This is 8. This is 6. So this cannot be 7 here. This cannot be 6. So this has to be a 6. This can't be 7. This can't be 6. 3 or 4, 3 or 5. This is consecutive. No 1, 2, no 2, 3, no 3, 4, no 4, 5, no 5, 6, no 6, 7, no 7, 8. This has to be 8 and 9. So this is 9. This is 8. We have a 1, 4, 6 combo. So this is 1 and 4. This is 1 and 4. This has to be 6. Which means this can't be 6. This can't be 6. Neither of these can be 6. So the 6 has to be here. So we have all those 6's, which forces 6 to be there. This is a 1, 4, 1, 4 combo. Okay, so this is 3. So 3 has to be one of these 2. So it could be 1 and 2. Okay, so this is 1, 5, 7, and or 9. So this is 7, 9. This could be 3, 7, 8, 9. So no 7. Oh, this can't be 7. This can be 3, 7, 8, 9, but it can't be 7. So this is 3, 8, 9. So we know this has to be 7. So this is a 7. This can't be 7. This can't be 7. So this could be 1 with 2. This cannot be 3. Okay, so that limits this to be 3. So 1 with 2. 5 with 4 or 6, but the 6 is not possible, and 9 with 8. So those are the possibilities there. This can't be 7 because 7 has to be in the circle, so 7's one of those 2. 7's one of those 2. 8 has to be here. 8 cannot be here or here, so 8 has to be here. So since 8 has to be here and 8 has to be here, this has to be 8. So this cannot be 8, which forces this not to be 9, so 9 has to be here. So therefore, one of these 2 is 9. So this is 1, 2, 4, and 9. Okay. This is also 1, 2, 4, or 9. This can't be 1. And this is 1, 2, 4, 5, 9. Okay, the 5 cannot be here, right? The 5 has to be one of these 2. Yeah. So this can't be 2. This can't be 1. Okay. This is 1 or 2 or 4 or 5. We don't know which. This we have 1, 2, 3, 4. So no 3 and 4. So this is 1 and 2. So this has to be 3 and 4. Which means this is 2 and 1. This can't be 1. So this is 5, 9, which means that can't be 5. So this is a 3. So we have 4. This is 3. This is 7. This has to be a 5. So this is 4, 2, 3. This is 7. No 2 or 4. No 4, no 4. This has to be the 4. So this becomes 9. And this is 1, 4, 5. This is 1. Hold up. Okay, so this is all kosher. So that's 4. We have to have an 8. So 8 has to be one of these two. This can't be 8. This can't be 8. So 8 has to be one of those two. This still has to be 9. This has to be 1. This is 4. This is 1. This is 5. This is 1 or 8. So this becomes 2. So this is 8. This is 1. So this cannot be 1. This is 2 and 9. So this has to be 9. And this is 5 and 8. So this is 8. This is 5. This is 9. This is 5. This can't be 7 anymore, which means this is 7. This is 8. This has to be 9. So this can't be 9. So this is 8 and 4. So this is 4. This is 8. This becomes 1. This is 3, 8. And we have 2, 9 here. So this is 2 or 9. This is 2 or 9. It can't be 9. 3 or 8. 2, 9, 2, 9. This is 2 or 9. This is 2 or 4. So this becomes 2. This is 4. This is 9. 2, 9, 2, 9. This can't be 2. So one of these is 2. So this is 2, 3, or 8. So we look at 2 or 3. So this can't be 3. This becomes 1, 2, 3, or 8. It cannot be 2 in it. So it's 1, 2, 1, or 1, 3, or 8. So it can't be 3. So this is 1, 3, or 8. This is 1, 3, or 9. So this becomes 1. This is 3, 2, 8, 1, 2, 3, 8, 1. This has to be 9, and this is 3. And that's the solution. Wow, I kind of went about it the wrong way. Um, it was important to notice that these circles had to be in the sets, and then recognizing that none of the numbers are in 3 of the sets. They're only in 2 at most. So that was the key there. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.